Okay, an update on the project. Let me just step back here a little bit, maybe a little better view of what's going on there. Yeah. So we got, we got a sprocket right there, a chain running up to the big wheel, winding wheel. Also got a sprocket there. On down to the gearbox is the chain. You'll notice that I just temporarily have this angle iron which is holding the bearings for this shaft. The angle iron is just clamped there for now. Got a little alignment setup I had going to get things aligned properly. Okay. Never mind that little camera stand there. It's just acting as it was acting as support. Okay. And that goes up to there. And same thing on this side. Not sure how good the light is here, but okay. And same thing over here, we're just got that clamped in place for now, and little quick clamp in the back, just hold the back of the angle iron up. And the reason I had to do that is a lot of small adjustments. As I talked about in the last video, how do you get two chains tight? With no chain tensioners on the same shaft. When the distance between two sets of shafts, or I should say center sprocket, is different. Yeah, that's where you have to get into things like, as I talked about before, some mathematics, but this is the implementation of the math. Right, hands-on stuff where I chose to clamp it in place and move it little by little, and use some alignment techniques. And even though you can't see it in this video, there's a little black magic marker on the edge of the rails here so I could just move things little by little and know where I was at. And as it turned out, for the chain length, the math on the chain length, it was dead on. I mean, the exact lengths were perfect, except for this one over here was off by a half a link, and that's because of just some small alignment issues that come into place with the way the gearbox is. When you're putting something together, you're going to find out that not everything works out exactly like the math, right? That's just be prepared for those types of things. So anyway, we have a little half link issue here that I'm working on, and no big deal. They make half links. I hate to use them, but sometimes it's necessary, and that's what that is right there. Okay, just a little half link. Right. So those come in handy sometimes. In this particular case, it's needed. So I'm going to use it on. So just some things that I have left to do. Quite a few things actually, believe it or not. I got to put collars on each end of the shaft. Split lock collars, one here and one all the way on the other end. That's so that the shaft won't walk, in the bearings. You don't want it walking around. Okay. Obviously I got to drill and put some bolts through here so I can take the clamps off on both sides over there as well. And let's see what else. I got to put master links on both chains because right now they're not master linked. Yep, still some things to be done, but getting pretty close hopefully here to run some weight again. And this time with everything being, hopefully much more sturdy and much more rigid. We'll see what happens. I'm also going to run some little angle iron that you see there on the floor. I'm going to run it from the end here diagonally up to there, okay, and just fasten to one of those bolts right there. That's so that we have some really good rigidity here, and we don't want this angle iron under load flexing around right up and down. So we're going to see what happens. Hopefully that's going to provide enough rigidity to where we have little flex. You know, I first tried a 3/4 inch diameter shaft, and it just had too much flex in it. I mean, as soon as I got it, I could, over a distance of, you know, this is about 4.5 feet, I guess. It had too much flex, so I went with a 1 inch diameter, much better. And as it turns out, pipe, you know, meaning not, this is solid material, but pipe actually is more rigid. So maybe next time I'll use pipe, as you see in this video. I don't know here, maybe it's just going to pick it up. But this is solid material. And piping, meaning there's a hole in the middle, actually is more rigid, less flex. It doesn't flex as much. Yeah, so very interesting. That's a true fact, by the way. May not be ultimately stronger, its breaking point, but it would be more rigid. So anyway, just want to show you guys where I'm at. Pretty cool. Pretty doggone cool. I got some little things I got to take care of. I don't know if the video is going to show it, but right here is a little bit of key sticking out with the keyway. Okay, the sprocket has a keyway in it and locks into the keyway here on the shafting. So it's a little too long and I can't get my collar up against it, so I just got to pull it out of there and cut it to length so that this split collar will be up against there, and this shaft, I mean this sprocket here won't walk around under load, right? So yeah, just little things you run across in projects like this, you know, little things that you got to spend the time. You should see how many to-do lists I have, and that's the only way you're going to get something done. You know, set your goals, write down the things you need to do, whatever you got for the day, okay, and go at it, and that's how you accomplish things. You know, one list at a time. So there it is, guys. I wanted to share that with you, and as always, thanks for hanging with me, and peace out.